In this video, we want to investigate the antiderivative of 1 over x. Now, I want to review with you what we know earlier, which is the antiderivative of x to the n dx. We know how to calculate this. What you do is you write x, you increase the exponent by 1, so you have x to the n plus 1. And then you divide by the exponent you just wrote, which is n plus 1, and then you have your plus c. So this is the antiderivative of a monomial. Now, the issue becomes what happens when n is equal to -1? You have a problem because you're not allowed to have a 0 in the denominator. So this video sort of handles that special case where n is equal to -1. Okay, so what we want to do is we're going to do this a little bit differently than you might expect. What we're going to do is we are going to use a derivative to show that something is an antiderivative. So let me explain what I mean. The first thing we want to do is we want to remind ourselves of the piecewise definition of the absolute value function. And what the absolute value function says is it says, look at the inside of the absolute value. If this inside thing is positive, so if x is greater than or equal to 0, then we want to just leave the number as it is. So if it's already positive, the output should just be x. Now what happens if that inside is less than 0? Well, when that inside part is less than 0, we want to make it positive. So how do you make a negative number positive? Well, you take that number and then you multiply by -1. So if it was negative originally, and then you multiply by -1, that's going to make the output right here positive. Okay? So now we want to really write down what is the natural log of the absolute value of x. And we can write that as a piecewise defined function as well. Now, when I write natural log of the absolute value of x, I need to make sure my domain does not have 0 in there because natural log of 0 is undefined. So I'm going to have natural log of x when x is strictly greater than 0. And I'm going to have natural log of -x when x is less than 0. Okay. Now, in order to differentiate natural log of x, I need to use the chain rule, right? The outside function is going to be natural log, and the inside function is going to be the absolute value of x, which changes depending on if x is positive or if x is negative. So when I take the derivative of this guy, when x is greater than 0, you're just going to have the derivative of natural log of x is just 1 over x. That's when x is greater than 0. Now, when x is less than 0, the derivative of the outside function, natural log, is 1 over something. We need to keep the inside, so that's 1 over -x. And then when we use the chain rule, we got to multiply by the derivative of the inside function. The derivative of -x is -1. So you could see that when I simplify this, I am going to get 1 over -x times -1. That's just going to be 1 over x. And that's when x is less than 0. Okay? So what do I notice? When I piece these two things together, I notice that this means the derivative of natural log of x is going to be, natural log of absolute value of x is going to be equal to 1 over x as long as x is not equal to 0. Now, since we see that the derivative of the natural log of the absolute value of x is equal to 1 over x, this means that the antiderivative of 1 over x is going to be equal to natural log of the absolute value of x, right? So by taking a derivative, we've actually shown how to calculate an antiderivative. So the antiderivative of 1 over x is just going to be equal to natural log absolute value of x plus c. And we can highlight that result. So, all right, this concludes our video on the antiderivative of 1 over x. Take care, everybody.